Alright guys, so welcome back. So in this video, we're gonna talk about waves. And so what is wave and how it works, okay? So if we think about wave, we can talk about there are some different types of wave, right? So we have some understanding of it. Let's say, well, the ocean, they got a wave in there. Let's call it the ocean wave, okay? And what else is a wave? So you might have heard like sound. Sound is a wave. Sound wave. And then light is a wave as well. Okay, all right, so these are some different types of wave, and then what are they? So in physics, we have to define what is a wave, what makes something a wave, okay? And then we can study it, what does it have in common, and how does it work? So, well, wave, we define it as a process in which energy is transferred from a point to another point without the transferring of matter, okay? Anything meets this criteria, and we call it a wave, okay? So let's look at ocean wave, right? So let's say this is the ocean wave. It's coming up and down and up and down, okay? All right, so if you imagine you are surfing or you are in the water. So what happens when you are surfing? Okay, ocean wave is probably not like that many waves. Let me just draw one, okay? So imagine this is the water and you're floating over here on your surfboard, with a big surfboard over here. What happens when the wave comes? When the wave comes, it actually does not push you forward. Some people think like, oh, wave is just gonna push you forward. Then that's how you surf. That's actually not how it works. So how it works, like the wave actually only lifts you up and then drop down again. Water actually doesn't go forward. Okay. So when the wave comes to you, it will be able to lift you up. Use a black pen. It will be able to lift you up and push you up to here, and then actually just drop you down again. It actually doesn't push you forward. So if you look at the wave have moved from here to here, right? But the matter did not move. The matter went up and dropped down again. So now you see there's a transfer of energy from one point to another point, but there's no transferring of matter. The matter just vibrates over here. So that matches the criteria. This is the reason why we say ocean wave is going to be a wave. And that's because it matches this criteria, okay? And same thing over here. Say sound wave, when I'm talking right now, and the sound moves from my vibration moves from my mouth and into the speaker over here, right? But there's no movement of air. I did not spit all this air into the microphone, right? And so this shows that sound wave is a vibration. It transfers the energy, but the matter did not transfer, okay? And then light wave transfer energy without transferring of matter. So that's why we get all this light over here, but there's no object actually shooting at us, right? Okay, but say what is not a wave? Let's say this pen, if I'm throwing the pen at you, if I throw the pen at you, and yes, the energy is transferred in this process, but the matter also transferred. So I can't say I'm throwing this pen and that is a wave. Okay. All right. So that's what wave is. And then wave, according to the nature of the wave, we can make it into two types of wave. One is called a mechanical wave. And one is called an electromagnetic wave. Okay, so what is mechanical wave? Mechanical wave, it needs material. So mechanical is kind of means material. It needs material for it to travel. This material, we give it a name, we call it medium. It needs a medium to travel, okay? So let's look at these three types of wave. Which one needs a medium for it to travel? So ocean. Without water, you cannot transfer this energy. Even though the water does not move, but you have to have a water to carry the wave, right? So ocean wave will be a mechanical wave. Okay, and the next one is sound wave. Sound needs air to travel. Without air, there is no sound. Sound cannot travel, okay? So I'm going to post a video on Google Classroom. You can have a look. So that shows sound wave. It's actually going to be a mechanical wave. Okay, and then what is the electromagnetic wave? Electromagnetic wave is just light. Okay, and we got something called the electromagnetic spectrum. Okay, which I will post it onto Google Classroom as well. So electromagnetic spectrum, it got all these different type of light. So the common light we talk about is called visible light. And that's just one type of light. And there are many different other types of light that we don't see. So we have, say, ultraviolet. You heard of ultraviolet that comes from the sun, it damages our skin. And we can't see ultraviolet, but it is there, okay? And then we have infrared, and then we have microwave, we have radio wave, and then over here we have X-ray, and then we have gamma ray. We talked about gamma ray. Gamma ray is the electromagnetic wave, okay? So electromagnetic wave spectrum includes all these ones. These are called electromagnetic wave. Electromagnetic wave do not need medium to travel. Okay, because as you see in space, it's all empty space. There's no air there to carry it. Well, the sunshine can still come to us. So that is because electromagnetic waves don't need anything to travel. Okay, and so if we talk about the sun, you can think about, well, the sun, we say, is having like a million basically nuclear bomb exploding every second. And so if we can hear it, it will be very, very loud, right? But we can't hear it because there's no air to travel to carry the energy, which is great for us. Otherwise, we'll all be deaf, okay? So, but there are light to coming, so which just give us energy on Earth, okay? All right. So then the next one is we have two types of wave. One is called longitudinal wave, and one is transverse wave. So these two wave separation is caused by the nature of the wave. Okay, and now we have a vibration. According to the vibration, we can make it to become longitudinal and transverse. Okay, so longitudinal and transverse wave, one is vibrating in parallel and one is vibrating perpendicular. Okay, what does it mean? So say longitudinal wave, if the wave is traveling this way, and the vibration is vibrating left and right as well. And where transverse wave traveling this way, but the vibration is going to be 90 degrees. So it's going to be up and down like that. Okay, so you have to remember it's the direction of wave and direction of vibration, whether they're parallel or or perpendicular. Okay, all right. So and then now we have some keywords. So we have one is, say, if I got a wave look like this, this is a typical wave shape. So this is the rest position. Okay, so we have a concept called displacement. So where's displacement? Displacement is where the object is from the rest position. Say if I talk about this point, so this is a displacement. So let's say it's 2 centimeters. Okay, and then say this point, the displacement is going to be 3 centimeters. Okay, the displacement of this point is, if I say this is positive, and I can say this is negative, say negative 5 centimeters. Okay, so that is what displacement is. We use the symbol D. Okay, the symbol D. Sometimes we use the symbol Y, so to represent displacement. Okay, all right, and then we have what we call amplitude. The amplitude is the maximum displacement. So the maximum displacement, this is the point where it's going to have the maximum displacement amplitude that equals to, say, 5 centimeters. Okay, this is here y here, this y is over here. So the maximum displacement is the amplitude. And then we got a wavelength. Wavelength is a distance between two successive corresponding points in a wave. Successive means from one to another. Okay, say if I have this wave over here, say what is a wavelength? Wavelength, if I choose this peak over here, and the distance from this peak to the next peak, that would be the wavelength. Say this is the wavelength. Okay, and we use a word called lambda. So let's say lambda is maybe 20 centimeter for this wave. Okay, so that's wavelength. Or if you choose this point, then this point is the next corresponding point. So you can go, well, that is the wavelength lambda as well. Or you can choose this point, or you can use the trough, the bottom, to the next bottom. Okay, so that will be your distance, or even this point to this point over here. As long as they're corresponding points, they're vibrating at the same thing, so that distance is gonna be your wavelength. Okay, all right. So and then I've drawn a transverse wave and a longitudinal wave. So, oh, I forgot to write this longitudinal wave. Make sure you add longitudinal wave into here. Okay, all right. So now we got compression, we got rarefaction, and then we got trough and crest. Crest is the top position, trough is the lowest position. Okay, and then over here we have another two concepts. One is frequency, and one is period. Okay, what's period? Period is the time taken for one vibration. One vibration from up to down to up again. So the time taken is one period. Okay, and then frequency is the opposite. So frequency is in 1 second how many vibrations you have. Okay, so let's have a look over here. T is how many seconds? Let's say 5 seconds. 5 seconds takes for one vibration. Okay, and what is frequency? Frequency is in 1 second how many vibrations you can have. Okay, and say that's going to equal to 1 over f, equal to 0.5 or 0.2. Oh, let's make it as a different number. Say if the period is 0.2 seconds, right? So that means for one vibration, it takes 0.2 seconds. Okay, for vibration it takes 2.2 seconds, and then over here frequency. Frequency means in 1 second, how many vibrations can happen? Okay, one vibration, 0.2 seconds. 1 second, we can have 5 vibrations. Okay, so how we do this is we can put it into the formula here. F equals 1 over t. If 1 divided by 0.2, that gives me 5 hertz. Okay, so this equation is super important. 1 over F equals to the frequency. Okay, so it goes, or you can go period equal to 1 over F, and that's the same thing. Okay. All right, so that's how we know how this works. Okay, so this is a very important lesson. Mainly we need to remember all these concepts, like all this mechanical wave, electrical wave, magnetic wave, like you all need to remember the definition. You need to remember what is longitudinal, what is transverse. So first understand it, and then two is remember it. So in the future we'll just be like, oh, displacement, blah blah blah, and amplitude, blah blah blah, calculation, and then you'll be like, oh, what is amplitude? And then you will struggle if you haven't remembered what is amplitude, what is displacement, what is longitudinal transverse. So all of this, and then period and frequency. You know period, you know frequency. Okay. All right. So last thing I want to talk about is say this. So how do we link this vibration to the wave? Is if you have one vibration, it's going to create one wave. If you have another vibration, it's going to create another wave. So this time, so the time taken for this wave to be created is going to be one period. Okay, the reason is because this is one vibration. The time taken for one vibration is one period. Okay, so say if you have a graph, take this away. So you might have two types of graph. So one type of graph look like this. Say time, say displacement. You got a wave like this. If they give you this number is 5, okay? So let's compare it to a different graph. Let's take this away. Yeah, and write this down in your notes as well, okay? So this is a displacement time graph. And then you might have this. Say this is still displacement. Let's give this 10. Okay, say displacement. But now this gives you position. Draw exactly same thing here. Let's say this number is 10. And this is 10 as well. And so what's the difference? Time over here, which you have, the unit is going to be second. And then position over here is going to be meter, okay? So what does this 10 meter mean? This 10 meter, it means the wavelength lambda is going to be 10 meter. This one basically is when the wave is coming, you took a picture of it. You say, oh, there's a wave like this. It's 10 meter this way and 10 meter that way. This is the picture at this one particular moment, okay? Where if you look at this one, the displacement time graph is according to time, we are looking at one particular point. This point is vibrating up and down, and then we stretch it out onto a graph. So this is at one particular time. And this one over here is same point, vibration during this time. Okay, the same point, vibration during this time. So now this one, it vibrates, takes 5 seconds for it to vibrate up, vibrate down, vibrate back. So this one tells us the period. It's 5 seconds. Okay, so this is how from a graph you can find the number, period 5, and from this one you can find the wavelength is 10. Okay, so 2 different graphs that serves 2 different purposes. So right here, this is displacement, position. Okay, so sorry, this is a bit messy over here. Okay, so now please draw these 2 into your notes as well. So as I've told you guys before, these notes I've written like 6 years ago now. So yeah, now obviously the teaching has improved, so you need to add this into your notes as well. Okay. So what I'm going to do in the future is I'm going to slowly moving this onto my computer, onto iPad, so that I'll have like new notes and can change anytime. So it's a bit more convenient. So yeah, so that's it for us today. So hope you guys enjoyed the lesson, and if you need, always go back to have another look and say, oh yeah, does that make sense? And have a look at the videos and information that I'm going to post on Google Classroom as well, so they all go hand in hand together. Okay, so yeah, I'll see you guys in the next lesson.